Kia ora Year 12, here's another question from the 2004 paper. This one's got two parts worth 9 marks altogether. The first part is a partial fractions thing. We have to express f of x, this thing here, in partial fractions, so that's fairly straightforward. And then we have to show that when x is small, small enough that we can ignore x to the power of 4 and the higher powers, that we can rewrite f of x as this. So that should make you think straight away that I'm going to have to do some kind of binomial approximation. There are other ways that we could do it, but that's the main one that's used in A level. So if you're looking at this and you go, I could do something else, like a Maclaurin approximation, that's fine too. Alright, so pause the video here and have a go at it, and then I'll go through both of those questions. Alright, so this is how the partial fraction part's going to go. Don't do what I did and copy the denominator incorrectly, because it will completely ruin everything. So just carefully taking a look at the three factors. We've got x minus 1, x minus 2, and x plus 1. So we're now going to write that out with partial fractions, and I'm going to have three terms, one for each of those. Right, please, when you're practicing this, don't skimp on the working. It is really important. So that's identically equal to a over x minus 1 plus some number b over x minus 2 plus c over x plus 1. Right, now multiplying through, we can see why this is going to work, because when we multiply through by the other factors, we're going to generate a bunch of quadratics that we're adding together. So we've got a times x minus 2 times x plus 1 plus b times x minus 1 x plus 1, and lastly plus c times x minus 1 x minus 2. Right, and we can see we're going to be able to use three factors here to do our zeroing thing, so that's going to be quite straightforward. We're going to let x equals 2 first. So 2 squared plus 7 times 2, take away 6, is equal to 0, coming from here, because that factor will be 0, plus b times 2 minus 1 times 2 plus 1, plus c times 0, because of this. So that gives me 12 is equal to, well, that's 1 and that's 3. 12 is equal to 3b. b is equal to 4. Right, now in the interests of time, because I think most of you know how to do that, I'm not for once going to go through the next two. I'm just going to write down what those coefficients work out to be. So we're going to then let x equal 1, and that will give me a. a is negative 1. And lastly, we're going to let x equal negative 1, and c will be negative 2. Alright, so if you do have trouble figuring out those, just email me or leave me a comment, and I'm quite happy to explain. Now, the next thing is to move on and try and get the binomial approximation. But first, I'm going to write that partial fraction expression out nicely. Okay, so here's what we can say about f of x. f of x is equal to negative 1 over x minus 1 plus 4 over x minus 2 minus 2 over x plus 1. Now, when we've thought about the binomial expansions that we've done, we've always had them in this form: 1 plus x to the power of n. N can be a fractional power, n can be a fraction or it can be negative, but we want to get it into this form first. So the very first thing we're going to do is a tiny bit of mucking around manipulation to do that. So let's see. The first term is pretty close to fitting the pattern. I'm just going to multiply numerator and denominator by negative 1. So that's going to be 1 over 1 minus x. So that's looking good. The next one, first I'm going to do this, is equal to minus 4 over 2 minus x. And the next one's equal to 2 over 1 plus x. So that one was fine. The middle one we're not there with yet. Let's just see what we've got. Well, we don't like this 2 in here. So with the first term, we can now write it as 1 minus x to the negative 1. But with this one, I'm going to divide the top and bottom by 2. It's going to give me this, minus 2 over 1 minus x on 2. And then this one is already good, so that's in that pattern. Now what do we have now? Nearly ready to go. 1 minus x to the negative 1 minus 2 times 1 minus x on 2 to the negative 1 minus 2 times 1 plus x to the negative 1. Now because we're really working with 3 little binomial expansions here, I'm going to do them each separately and then put them back into that big expression. I'm doing that because I think the chances of making mistakes if I do it in one go are quite high, but you might disagree. Alright, so here's my first one. 1 minus x to the negative 1, which is equal to 1 plus negative x to the negative 1. And we're just going to go to the cubed power. So it's going to be 1 plus nx, so using my binomial formula, it's going to be negative 1 times negative x plus negative 1 times negative 2 over 2 factorial. And the last one, right, now I want to clean that up straight away. We're going to get 1 plus x. I'm quite happy that the coefficient here simplifies to 1. And I'm going to have plus x squared. Here again, the coefficient is going to simplify, but to negative 1, because I've got 3 negatives multiplied together. So that's going to be minus negative x cubed, which gives me 1 plus x squared plus x cubed. Okay, on to the next one. 1 minus x on 2 to the negative 1. So that's going to give me 1 plus n, negative 1, times negative x on 2. Whoops, 2 factorial in there. Alright, so we've got to clean that up. We'll do that on the next slide. So that equals 1 plus x over 2 plus x squared on 4 minus a negative, so plus x cubed on 8. So that's the second one done, and the last one is the easiest of the 3. It's just 1 plus x to the negative 1. Now some of you probably will know that one as a pattern anyway. So there we go. So now we've got the 3 separate worked out expansions, but what we needed was f of x. So f of x was equal to 1 over 1 minus x minus 2 over 1 minus x on 2 minus 2 on 1 plus x. So we need to put them all back together now. And we've got our 3. So hopefully you've got a nice big bit of paper with you, because the way I'm going to do this is to line things up in place value order to keep it a little bit tidier. So f of x is equal to 1 plus x squared plus x cubed. Now on the next line I want to have minus 2 times the expansion. So that's going to give me take away 2 minus 2 x over 2 minus 2 times x squared on 4 minus 2 times x cubed on 8. And then the last line is also a minus 2, so it's minus 2 plus 2x minus 2x squared plus 2x cubed. So now, cleaning all of that up, what do we get? Well, we get 1 minus 2 minus 2, negative 3. Here, that simplifies, so I've got x, take away x, plus 2x, so that's good. And here, that simplifies to give me minus a half x squared. So working with this lot, I've now got minus 3 on 2x squared. And lastly, in here, that's a 4. So let's do this bit explicitly. I've got plus 3 minus 1/4 x cubed. Sorry about the background noise. Minus 3 plus 2x minus 3 on 2x squared plus 11 on 4x cubed as required. Okay, now that was long and somewhat tedious, but hopefully a few things in there to remind you about how we do binomial expansions and how to set your working out. Thanks for your patience if you're still watching. I think there might be a chocolate fish if you're still watching. So email me and tell me that you watched to the very end, and I promise I will deliver it on the first day of term.